So dynamic load. So let's go ahead. So you guys know that dynamic load is opposite of static load. So static load is having the definition that the load should not change its direction or magnitude with respect to time. Okay. So dynamic load means either load's magnitude or direction. So magnitude or direction, any one of it, if it is changing with respect to time, we call it as a dynamic load. So if magnitude is constant but direction is going on changing, we call it as dynamic load. Though direction is constant but magnitude goes on changing, we call it as a dynamic load. Clear everybody? Understood? So kindly put the definition here. So load acting on the mechanical component or machine element which is changing its direction or magnitude or both with respect to time. So if at least one value is going on changing with respect to time, we call it as a dynamic load. So kindly copy the definition. We'll see some examples. So like I said earlier, your weight on the plank of the bench is a dynamic load. So your weight magnitude will be there for some time till class is over. So once break comes, you'll be going for a break. So your weight will not be there for the 15 minutes or 10 minutes. Then again, once class starts, you'll be sitting on the bench, so weight will be there. So with respect to time, the magnitude is going on varying. So non-zero for some time till class is getting completed or the break gonna start. So in the break time, the weight is equal to 0, and again after the break time, it's going to be non-zero. So it's going to change from time to time. It's an example of a dynamic load. You take traffic on a bridge. So whenever some vehicles are there on the bridge, so the weight will be there. So whenever vehicles are not there, it's going to be 0. Understand? So in peak hours, traffic increases, so weight on the bridge will become very, very high. In lean hours, when traffic is going to be less, so the weight goes to be very lesser value there. So it goes to higher value, lesser value, higher value, lesser value. It goes on varying like that. So dynamic load, the traffic weight on the bridge is nothing but a dynamic load. Understood? Clear? So most of the cases, if you take the failure cases, wherever failure happens, most of the cases failure happens by dynamic loads, because in static loads what we do is generally we know the strength of the material, that is SYT or SUT. So you make sure the load will not be giving rise to that amount of stress. So you'll be knowing that if I give rise to a stress of 100 megapascal, it will fail. So I will not allow till 100 megapascal. So the value of stress will be some 50, 60, 70, 90 only, like that. So you know the strength of the material and you'll be making sure it is not going beyond that. So unless due to some mistake it is going beyond that, failure will happen. That's all. Clear? But in dynamic loads, what happens is the metal behaves in a different way, completely different way. I will tell you in a more detailed way in the coming slides how actually it behaves and what's the problem with that one. So due to this variation, what happens is the metal will fail abruptly. And due to that, what happens is you're gonna see that the dynamic loads. Due to this, you're gonna see that most of the failures are happened due to these dynamic loads only. Because we're gonna control the failures. We can control the failure by static loads, but we cannot control the failure by dynamic loads. Understand? So today, let's assume that like you are going to give GATE examination. Okay, let's take some. You are going to give some RB examination. And you got a center which is some old college. So you went to the college, it's a very old college, and you went to some bench. Okay, you went to the seating arrangement and there is a bench, and you have to sit on the bench and you have to give the exam. So imagine that it's a very old college and the bench is also very, very old. So now you know that like bench is intact, so you think that bench will not fail at all. So just if you see that no dust is there, you'll sit easily and you'll be going on giving the examination. All of a sudden, due to your movement and all these things and all, suddenly the bench fails. The bench breaks and will be falling down. So you see that though earlier, after a few years back when the bench was very new, though a person of your weight was sitting on the bench, the failure was not happening, but today it got happened. So abruptly, suddenly failure will happen in dynamic loading cases. So which we cannot control. So now after listening the content of this chapter, we can understand how to control, how to be optimized, how to be taken care regarding this. But with this knowledge, with the knowledge we have till now, we can simply say that we can take care regarding the failure of a static load, but we cannot take care regarding the failure of a dynamic load. Due to this reason, in real life scenarios, we have most failures which are occurred by dynamic load itself. Okay, so you can write on this note point here. So most of the failures most of the failures in real life are occurring by dynamic loads. Write on this note point here. So most of the failures occur by dynamic loads only. So very few cases. So in VB Bhandari textbook they given a statistical data also. So out of every 100 failures, 85% failures are, after every 100 failures, 85 failures are due to dynamic loads only. So 85 is to 15. So due to static load, 15 cases. For dynamic load, 85 cases. That much dangerous it is. So that's why we are dedicating this whole chapter for this. So we'll study this and we'll solve numericals and we'll get answers for all the questions. Is it done, everyone? Copying is over. Also write to this note point on the secondary screen here. So dynamic loading is also called as fatigue loading. So here we should understand the concept of fatigue completely. So once you are done copying, I will explain about fatigue loading here. Kindly copy the note point below that. Done, everybody? So dynamic loading means the load which is changing its direction or magnitude with respect to time. And this dynamic loading is also called as fatigue loading. Okay? Now, next term we should understand here, that is fatigue failure. So fatigue failure is very simple. So if the failure is occurring due to a dynamic load. So till now we have discussed about only those cases where failure is occurring due to a static load itself. Okay? So when the load was not changing its direction or magnitude with respect to time. Okay? So now fatigue failure means the failure is occurring due to a dynamic load. Understand? So kindly write down the definition. The tendency of the material to fail under a dynamic load is called as fatigue failure. Well, understand about the concept of fatigue. Please wait. For now, time being, please copy the definition of failures here. The definition of these terms here. Let's understand about this fatigue concept here. Everybody listen carefully here. First of all, let's understand a general sense and then let's understand a technical sense. So general sense means in the day-to-day life sense here. Okay. Let's assume, firstly, once I start the lecture, I given you this question. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9-digit number you have to divide by 5, 4, 2, 3, 8. So some 5-digit number here. So if I give this question and ask you people to get the answer without using calculator. Okay. So let's assume that is the question I given you at the starting of the lecture. When you came to this lecture with a fresh mind. Almost everyone in the classroom will be able to give me the answer here. Because simple primary school maths, so you can take time, but you can easily get the answer there. Okay, so everybody will be able to get the answer. Everybody is capable of getting answer for this particular question. Let's assume I took continuous class of 6 hours or 8 hours or 9 hours, continuous class without break and all, anything at all here. And then at the end I given this question. Let's take the other case where I given this question. Okay, I have given this question to you after a continuous class of 6 hours or 8 hours. You're not given any rest at all, nothing at all. What happens? If you ask you people to solve this particular question, you'll try to use some shortcuts of getting the answer by using calculator. Okay? So let's assume I have restricted you to not to use the calculator again. So without using calculator, you have to get the answer. So now everybody will try, but very few people or half of the crowd or 60% of the crowd only will be giving you, will be able to get the right answer. Remaining 30% or 40% will be ending up getting the wrong answer. Why? What is the reason here? So the reason is fatigue. Fatigue means what? So fatigue means basically decrease of capacity over time. Fatigue means basically decrease of capacity over time. So you are capable, but over time you'll be losing your capability. Understand? You're capable. You're engineering student, so you can solve a primary school level question here, but due to your continuous listening of lectures, over time, you lost the capability. So fatigue means basically losing capacity over time. So if you're talking technical sense, we should be replacing that capacity by strength here. So fatigue means basically decreasing of strength over time is called as fatigue. So if you take a fresh aluminum specimen and you found out that SYT value or yield strength value in tension is equal to 100 megapascal. But if you use it for some appliance, let's assume you use that aluminium for aircraft, and aircraft was used for some 5 to 6 years. Okay, aircraft was used for 5 to 6 years there. So now after that, you take the specimen and try to do the testing. Then you'll find out that the strength will no longer be 100 megapascal. That will be the real scenario here. So fatigue means decrease of strength over time. So it will be occurring only due to these dynamic loads. So if you take a fresh specimen, if SYT value is equal to 100 megapascal, then use it for, you have to use it for some time. And in these years, dynamic loading should be there. So if I use the aluminum to make an aircraft body, so aircraft body will be experiencing dynamic loads because constantly, it will be taking passengers from one place to other place, so it will be definitely experiencing some dynamic loads. So what happens after that? You take the specimen and you do the tensile testing, you will find out that SYT value will be less than 100 megapascal, or maybe let's say it has some 50 megapascal there. So the strength decreases over time. So this decreasing of strength over time occurs only when there are dynamic loads. There are only two types of loads anyways, static and dynamic. So static loading will not cause any fatigue. Dynamic loading will give rise to fatigue. Understand? So static loading will not be giving rise to fatigue, but dynamic loading will give rise to fatigue here. Understood? So this is the definition of this fatigue here. So once it is done, we'll discuss about endurance strength or fatigue strength. Kindly copy the things from the board and put the title from the next slide. Okay, so I'll explain this thing using an example. In fact, the coming terms also I will use this example only to make you understand here. Ipsita, fatigue, I said that it's a condition where strength decreases over time. Understand? So what I said was, you take an aluminium or some specimen which was a fresh specimen, you do the tensile testing and try to find out SYT or strength of the material. So you'll be getting 100 megapascal, let's assume. So if you're getting 100 megapascal, afterwards if you use the specimen for some application for some years, 5 to 10 years, you used it, and constantly it was experiencing dynamic loads. So what happens is, after those number of years, if you do the testing, you'll see that strength is no longer 100 megapascal. It will be less than 100 megapascal, maybe 60 megapascal or 50 megapascal. So the phenomena of decreasing of strength over time due to the application of dynamic loading is called as fatigue. That's what we are discussing till here. Okay. Now we are going with this particular endurance strength or fatigue strength. Both are same here. So try to understand properly here. Let's imagine a new bridge was unveiled or new flyover was unveiled, and today vehicles are allowed to pass over the bridge. So let's plot the strength variation with respect to time of this particular bridge. Okay. So this is the time 0. So time is equal to some years, like year 1, 2, 3, 4, 5 and so on like this. Okay. Now, if you take the material of the concrete or the pillars of the concrete and from the pillars of the concrete, and if you do the testing, you might find out that the strength is some value. Okay, so it is not at all started. Dynamic loading is not at all started. So T is equal to 0 means static loading itself. So time is not varying. Time is equal to 0. We are talking at particular instant itself. Okay, so at the point of time, it is having some strength. Let's assume that strength is corresponding to weight of 100 lorries. Okay, so I'm giving the strength in terms of weight of the lorries. Okay, I'm just giving in terms of the weight of the lorries there. Now, if you are using that particular bridge for some years, okay, everyday traffic is going, traffic is coming, traffic is going, traffic is coming. So the traffic weight is also going on varying with respect to time. Because like at peak hours traffic will be high, on lean hours traffic will be lesser. Okay, so what happens is, if you do the strength testing afterwards, you will find out that strength got decreased. If you still wait for some more years and then check it, so you observe that strength will be going on decreasing, maybe linear way or any particular way, but strength value will be going on decreasing. So anyways, we have decided that, or we have understood this concept where strength goes on decreasing with respect to time. We call the concept as fatigue. So the bridge is experiencing fatigue. That's the reason why strength is going on decreasing with respect to time. That's a value here. Understood? Now, here, its strength is going on decreasing, but that doesn't mean that strength is equal to 0. Strength is going on decreasing, and always strength value is related with respect to time. So if you are taking more amount of time, strength will be decreasing to a very high value here, or to a very lesser value here. Okay? So more is the time, lesser is the strength. Lesser is the time, more is the strength value here. Understood? So this particular values are nothing but strengths only, but at some point of time which are left over. After some point of time. That is a strength that is left over after some point of time. For example, you take this thing here. So this is the amount of strength after this amount of time here. So maybe 5 years. This is the strength of the which is left over in the bridge after 10 years. Understand? So that is given the name as endurance strength. We cannot simply call as strength, because strength, we have given the name as strength with respect to static loading. So the default name strength is with respect to static loading there. Now endurance strength means, endurance word is there means immediately you should be keeping in mind that it is with respect to dynamic loading. Due to the complete application of, continuous application of dynamic loading, your strength will be going on decreasing here. And whenever you talk about endurance strength value, always that should be related with respect to time. Because endurance strength value after 5 years is different, endurance strength value of 10 years is different, and so on like this. Understood? Endurance strength value from 0 years to 5 years, 10 years, and so on, it will be going on changing here. So this strength, whatever is left over after some point of time, is called endurance strength, and whatever the time up to which it can withstand this particular stress or this particular axis, we call it as fatigue life. So this is also called as endurance strength or fatigue strength. Okay, and this axis we call it as fatigue life. This axis we call it as fatigue life. That means here strength of this particular bridge will be going on varying like this. So on 10th year, by any chance, if you make sure the traffic, by any means, the traffic on the bridge is reaching this particular value of stress, immediately it will break or the whole bridge will collapse. It's a very simple example there. So in real scenario, it will not happen, but I'm letting you people know here. So the strength will be going on decreasing over time. Once you make sure the stress is reaching the value of strength, automatically failure will happen. So we can say that it has sustained for those in a number of years. So always endurance strength or fatigue strength is related with respect to fatigue life. So always there will be a relation between both of them. So don't think that it's going to be always a straight line here. So this going to be decreasing. Strength will be going on decreasing with respect to time, but it can vary in a linear way or in any other way. So we're going to see some examples in this chapter only, so you can understand from that one. Okay, everyone. So copy the diagram and also copy this particular title here. The stress at which the machine element subjected to dynamic loading is failing is called as endurance strength. So here it is experiencing dynamic loading here. Understood? Kindly copy, everyone. Okay. Now listen carefully, everybody. Let's imagine there is a very old bridge. Very old concrete intact bridge. So it's not like something, it's already half demolished like that. So it is completely intact, but it's very old bridge, some 50 years, 60 years like that. Okay, so obviously the bridge has to be blocked for, the bridge should not be used for heavy vehicles like lorries, etc. Okay, let's imagine a person of 60 kg weight is passing over the bridge. Intact, very old bridge. Okay, will the bridge will collapse? If a person of 60 kg is crossing over the bridge which was very old, will the bridge collapse or not? failure will not happen. Not necessarily failure will happen. Failure will happen. Understand? So that means that this particular curve will go on like this. That means strength will decrease over time, but that doesn't mean that strength will become zero after this amount of time. If I say that like after 60 years, like just assume the curve goes like this, okay? After 60 years, strength is equal to 0. If I say after 60 years, strength is equal to 0, if I say in that way, if I say this is the case of the particular bridge, then that means that, okay, so if a 60-year-old bridge is there, if at least 60 kg person is also standing on the bridge, immediately the bridge should collapse. Because it cannot take any value, because strength is becoming 0 now. Strength became 0 now, so it cannot take any value of the load. Understood? But this is not the case. So in real scenario, what happens is the components will be having strength variation with respect to time in this way. Strength will decrease over time like this, but afterwards it becomes a horizontal line. That means if you have a case where the 60 kg person is crossing over the bridge, if this is the value of stress applied there, then you see that corresponding life is at infinity. For this particular case, you have life to be 10 years. For this particular case, life to be 5 years. In the same way, for this particular case, you will get time is equal to infinite. Time is equal to infinite means it will not fail at all. Understood? So, the strength variation with respect to time for a component which is undergoing dynamic loading will be in this way. Understand? And this particular limit below which this happens, like life becomes infinite, this particular limit is given the name as endurance limit. Endurance or fatigue limit. Endurance or fatigue limits. Understand? So, if you apply load in such a way that stress is below this value, then never ever failure will happen. So below this value, never ever failure will happen. So endurance limit is nothing but endurance strength corresponding to infinite life. So below that value, you will have infinite life. The component will never ever fail at all. Okay, but unfortunately, the endurance limit for any material for any loading condition will be very, very less. For example, I'll put in this way here. Saurabh Kumar, why so happened? This is the way in which the metals are behaving. This is completely experimental result here. And that's the reason why I'm taking examples. Okay, so I was telling that endurance limit for the components in any loading conditions are very, very less. I would like to give an example here. Imagine you purchased a mixer or juicer which can be used to make juice every day. Okay, so definitely like you are using mixer or juicer every day means like after some 5 years or 10 years it will fail. So mostly nowadays people will not be keeping old appliances. They will be changing it after 3 years, something like that. Let's imagine you are using it for some good number of years. So this will have a life of finite life of some 5 years like that. If you want to have the mixer, if you want to use the mixer for infinite, forever, so then ideally speaking you should be using it for crushing a toothpaste, crushing only bananas, crushing like some very soft material. So that means it can take, that means the endurance limit value is that much small that you should go beyond that value. So most of the cases will be applying loads which are above this only. That's the reason why any component which is experiencing dynamic loads will be failing after some point of time. Understand? So very, very rarely we see a component is there forever, unless it is a monument like Taj Mahal, etc. Okay, so why these structures are there for these many number of years? Why a building which was constructed some 10 years back will be asked to get demolished, or it will be like 20 years back building will become very old and it will be developing cracks? The reason is Taj Mahal and all the buildings, like I'm talking about mainly Taj Mahal because it was made up of Makrana marbles. It's a very strong material. So the material and the loading, because always the strength depends upon the loading as well, as far as this endurance strength is concerned. So the endurance strength of the material is having higher value of endurance limit. Okay, so if you take the wind force acting on the Taj Mahal, if you take the mostly the wind force itself. Okay, so wind force acting on the Taj Mahal. So the stresses produced by the wind force are far lesser than endurance limit, so that will not be experiencing failure very fastly there. So it can have infinite life there. Ideally speaking, it should have infinite life there, but due to other reasons like pollution and earthquakes, other things and all taking care, we cannot achieve infinite life very easily that much. So if you take simply the wind force, it can have infinite life. Understood everybody? Clear? That's the reason why they are like they're built on very big base, all these things and all. So the force will be acting on that particular element or the machine element or structural element there, but endurance limit of the component is very high. Are you able to understand this thing here, everybody? Clear? So few doubts are there here. You can put some more doubts if you haven't understood anything, whatever I explained till now. It means so dynamic load bearing part of machine have infinite life. Example, propeller shaft. Makesh, what I'm saying was, if your component which is experiencing dynamic load is experiencing a stress less than its endurance limit, then it can have infinite life. Are you able to understand? So here, the life is depending upon the stress that is actually being applied. So if you have stress applied which is higher than the endurance limit, then you cannot have infinite life there. If you create a scenario where the stress applied or stress produced inside the component is far lesser than endurance limit, then you can expect endurance, then you can experience the infinite life to be there. Okay, but that is not the case in every real scenario. This particular load, whatever I'm using, that is only for our reference. Okay, reference in the sense like if you get the value of stress, if you simply multiply by area of cross section, you will be getting the value of load. So only you are just dividing or multiplying a constant. So here, this particular endurance limit basically is a stress value. If you take strength of the material, yield stress, ultimate stress, all these things are stresses only. There is nothing having units of load. This endurance limit is also having the units of stress itself. Endurance strength is also having units of stress itself. Understand? Or Newton per meter square, not strength here, not load here or newtons here. Okay? Endurance limit is greater than the load to be encountered. Kumar Vishesh, is it clear now? I think you just got taught in a wrong way. Remaining people, is it clear, everybody? Is this curve for all materials? No, that's what I'm saying. I just drawn a generalized curve which is showing that endurance strength will decrease over time. How it is decreasing, what's the value of these many years and all, everything we'll see for case to case in coming slides and coming concepts. Okay? So I'm just briefing it out. So if you take a component which is acting or experiencing dynamic load, its strength decreases over time. So strength will be decreasing over time. So whatever the leftover strength is there after some amount of time, we call it as endurance strength. Okay. So, and the corresponding life, we call it as fatigue life. So endurance strength is also called as fatigue strength here. But this will not become zero, or it will not achieve a case or after some amount of time that strength is equal to zero. So strength will be there. So minimum strength will be always maintained no matter whatever is the time for which it is being used there. Okay. So if you apply a stress, if you create a stress which is less than the endurance limit, then it can have infinite life. Regarding that, I'm actually talking here. So very rare cases are there where we will be applying a stress which is far lesser, which is lesser than endurance limit, and will be achieving a situation of infinite life there. So most of the cases, 99.9999% cases, we have finite life cases only. That means like we'll be applying stress or creating stress which is more than endurance limit, and will be having certain amount of time up to which we can be using it. You take a bridge, so bridge can be used for some 50 years maybe. Understand? If you take a building can be used for some 50 years maybe. Like that. Okay, everything will have some amount of life. So there's nothing like it will have infinite life. Unless in that particular case, you found out that stress acting on the component is far lesser than endurance limit. Understood, everybody? So what if stress applied is greater than the endurance limit but less than the endurance strength? Ipsita, I think your real name is Ipsita here. I hope it's okay to call you with that name. Okay, so if you guys think to call with any of your real name, you can let me know. Endurance strength is any value here, Ipsita. Endurance strength is any value. The whole thing itself is a y-axis. The y-axis every coordinate endurance strength itself. So endurance strength after 5 years is this much. Endurance strength after 10 years is this much. Endurance strength after 15 years may be something. Understand? So endurance strength for infinite life is endurance limits. Understand? So endurance life for infinite life. Okay. So endurance strength value for infinite life is equal to endurance limit here. So stress value is less than that value, the component will have infinite life. That's it. Clear now? Understood? If it is below this value, it will never fail. If it is above this value, that means stress applied, induced, is more than this endurance limit, definitely it will fail. That objective is that much big that we can't study everything in this particular lecture itself. So we'll be studying our higher studies. If you're taking machine design as your specialization, you'll be studying more. If you take if you're doing PhD, you'll study still more. Understood? You'll take some particular loading condition, you'll take a particular project, and you'll be involved with that one, and you'll apply these concepts. Understood? So knowing endurance limit is very, very important. Here we will discuss regarding that thing in a very detailed way in this particular chapter. Okay? So I hope doubts are clear. So we'll go with the coming concepts after the small break. So shall I go ahead? So everybody clear about the concepts we have discussed till now? The basic concepts of dynamic loading we have studied. So the definition of fatigue, what is fatigue loading, fatigue life, endurance strength, endurance limit, all these things. So all we understood was strength decreases over time in dynamic loading case, and it will not become zero. So it will go to some lowest limit. That limit we call it as endurance limit. So we have seen everything in this graph itself. Okay, understood? Okay, everybody. Okay. So one very important thing, just keep in mind, and I will write down here also. You can copy. Okay. So what I would like to tell you now is this endurance. If you take strength value, basically. So whatever the strength values are there in static loading cases, that means SYT, SUT, they are experimental values. Okay, so they don't change with respect to time. Understand? So those are experimental values and they don't change with respect to time. And they depend upon only material. So strength, so SYT and SUT, that means strength in static loading cases are experimental. Strength in static loading case are experimental. They depend on only material. Okay, this is a very important point. So they depend upon only material. That means you take aluminium, which you got it. You take aluminium, which you got it, which you have produced in India. You take aluminium, which is produced in US or any other country. So all the aluminiums will have same value of SYT. Okay, in the same way you take any other brittle material. So let's take cast iron. Okay, so the cast iron having, like cast iron means it should be having composition of 4% carbon, 96% iron. So you take that cast iron from India, some other country. So whatever may be the country, whatever may be the place, so all will have same value of SUT. That's the thing here. Now we have understood the strength regarding static loading cases. Now you take strength regarding dynamic loading cases. So strength in dynamic loading case is nothing but endurance strength here. So which you have discussed till now. So this endurance strength, so this will depend on material. One thing is common here. But here it depends upon the type of the dynamic loading also. Okay. So endurance strength depends on material and also dynamic load. Okay, so the type of the dynamic load means, so the dynamic load can be of any type. Okay, so I can like if for example you take the traffic on a bridge. So if you plot the load with respect to time, okay, how the load is varying. So if you take for a particular day, so morning time, like early morning traffic will be very, very less. Immediately traffic will shoot up, and then traffic will be very, very less, and then in the evening again traffic will shoot up. Okay, so like this will be having a pattern, some pattern here. So this may be recurring or non recurring. Sometimes on Saturday, Sundays traffic will be very, very less, on peak hours also. So it will be having some variation. So this is the one type of dynamic load here. Now you take something else. So I'm taking some other example here. So some other example is I'm taking a plank and I'm hitting the plank with a hammer. So I'm hitting a plank with a hammer. So there you see that suddenly whenever I'm hitting, the load will go to maximum, and suddenly after that load will disappear, then goes to maximum, disappear, load goes to maximum, disappear, and so on like this. You see that there is some difference between this thing and that thing. Okay, so completely random in nature. The way in which you are applying the load, the graph will come out. So every dynamic load is completely unique on its way. Okay, so unique on its own. So if they are coming same, it's completely coincidental. Coincidental. I hope everybody is understanding. Every dynamic load is unique on its own because it is completely produced with applied load here, and if they are coming same, means they're completely coincidental. It's completely due to coincidence. They're completely coming same itself. Okay. Now, so this particular strength variation, endurance strength after some point of time, how this graph will be varying. So this strength will be going on varying with respect to time. Not only depends upon the material, but depends upon the type of the loading also. So just keep this thing in mind for now. So later in the coming concepts, when we go into the remaining part of this chapter, so which we're going to discuss today, you'll understand a more better way. Understood? Just write down these two things on a side so that I'll be having an idea that endurance strength not only depends upon the material but also the type of the dynamic load here. Understood? And you copy everyone. So we'll go with the next one, stress flow lines.